now the third time. I think I get more and more what's the English word for it? Nervous about it. It's almost the same word in German.
Yeah, I understand. Well, I'm excited to talk with you. It's always nice to chat. It's always been fun. So yeah, looking forward. So yeah.
No, thanks. Yeah, thanks for taking the time, Eric. Can't remember how we originally came in contact. I'm not 100% sure if it was because of a paper of you or because I saw you on Twitter. I just reached out to you, and yeah, I remember that I think we had two talks yet. It was always very funny, very vital, and a lot of energy in it. So yeah, I'm looking forward for today's call. I sent
Thanks.
you over a few questions, and even though I do like my own voice, so I would prefer your voice here, and maybe you can just tell me a little bit how you came in contact with yeah, what you're doing at the moment, and yeah, maybe we can have a little chat.
Sure. So maybe I'll even talk more immediately about what I'm doing at the moment. So currently, I'm a robotics research scientist at the AI Institute. And so, really, kind of our general goal is to develop generally intelligent robots. And that involves both developing smart hardware, smart software, putting it together to be able to get these kind of embodied agents out into the world to help society at large. And so my kind of background, which I can also dive into a little more,
Please.
is more on the software side of things. And so, though I've been really enjoying getting to learn more about hardware, but with my kind of experience more on the algorithmic and AI kind of side of things for robots, the kind of team I work on at the AI Institute, I think reflects a lot of what my research has been, which is called Watch, Understand, Do. And so really what we're interested in doing is kind of what it sounds like, which is what we wanted to be able to do is have robots watch humans do some tasks. So have the robot understand at some level what the human is doing so as to enable the robot to do it itself. And so really that kind of general purpose end-to-end interface of making it really easy for humans to interface and interact and communicate with robots as they do with normal other humans, so as to teach them how to do useful things in the world, and then enable those robots to do useful things in the world generally and robustly and safely. I think really captures all the kind of things I've been kind of working up to in my own kind of career. And maybe even to just give kind of a background, kind of starting more from the earlier parts, I guess. So since I was younger, I've always been interested, I guess, in kind of the STEM area. My dad is a doctor, and so always pushed me more into medicine. And so early on, I was really interested in neuroscience. But more into like middle school, I got exposed to computer science through like web design. And so I started really getting interested into programming and wanting to kind of mix these two kind of ideas of like neuroscience and computer science together. And about high school, I became aware of artificial intelligence, and I think that really kind of put the two things together in my mind, because it was really kind of about, hey, I could like develop computer programs that solve a lot of problems. I get to study a bunch of different things. It was kind of, I thought, like a really fun synthesis of the two. And what's really interesting actually is I knew in kind of high school I was interested in AI, but I didn't really know what for so much. But one thing I knew particularly was I didn't want to really do robotics, funny enough, because in high school I got involved in this whole robotics team that I had a really bad experience with, mostly because I felt like robotics was really caught up in the mechanical side and having to get your hands
Mm,
dirty. I really like just programming. And so I thought robotics was like the one thing I didn't want to do. But what kind of really changed me is for my undergrad, I went to Brown. And so there I studied computer science and applied math in my undergrad. But I took an AI class and got introduced to a professor there whose actual experience was in AI, background was in AI and robotics. And I was like,
mm,
oh, like, I want to take AI, but like I don't really care too much about this robotics side. But what she really taught me, Stephanie Telix, was really about the idea that what's really cool about AI for robots is that you can have AI go out and collect data in the real world, and actually like like the world is a really complex environment. It's a really cool one to study, especially because it has all the structure of physics. And I always was interested in physics because I love math, and so I think all the things really came together to make me really think, wow, like robotics is a really cool problem to study for AI. And so that really got me during my undergrad. I started doing research with
Sorry,
Stephanie.
and when was that?
Oh,
Just
yeah, yeah.
for
So yeah, to give some background, so I I started my undergrad in 2014, and then I graduated in 2018 with my bachelor's in applied math and CS. And then after I had done some research during a few years during my undergrad, which was really focused on human robot interaction with like virtual reality interfaces, as well as designing machine learning and AI algorithms to enable intelligent decision making for human robot interaction. So, like having robots um, clarify their uncertainty about the world by interacting with humans or by searching and asking questions and things. So, just generally intelligent planning algorithms. And so during my undergrad, I knew I really liked research, but I wasn't really sure what I wanted to do too much still. So I decided I think I should maybe just do a PhD, decide like, because I really enjoy research. And so I actually ended up doing my PhD at Brown under the same professor. And then later on, I would work more with George Conadaris, who's another professor at Brown. And so I did my PhD there. And yeah, and then so I did my PhD from 2018 to about 2023, which was around when I graduated. And then I started a job at the Institute as a research scientist. And I've been there for about 6 months now.
I think the not I think the last time we spoke, or no, the first time we spoke, you were just about to enter the institute. I think they dropped the Boston Dynamics AI Institute. It's now just the AI Institute, right? Another thing is, I think we talked about that here, at least in Germany or in Europe, it's you have the bachelor degree. It's most likely like a 3-year degree, and then the master degree, and then you do the PhD. Versus you did the bachelor degree, and then you do an kind of a combined PhD where the master degree is included. So it's 5-year program, you said?
Yeah, it's normally like within 1 to 2 years that you get your master's degree in the PhD program, unless you already have your master's, at which point you don't have to do certain credits and things like that as
Mm.
well. But yeah, exactly. So I was right after my bachelor's, I went straight into the PhD.
I have a lot of students that are so my account on LinkedIn. I saw a lot of people that are following me. They are students, and they're doing computer science. They do mechanical engineering, aerospace engineering, but robotics as well. So it's interesting to see how you came. You said that you're trying to avoid at high school. No, yeah, middle school, that you're trying to avoid robotics, especially throughout a bad experience, and then finally somebody at university inspired you to go down that path. I'm not 100% familiar with the situation in the US when it comes to going to certain universities. We do have increasing numbers of people here in Germany going to universities as well in the last 5-10 years. I would say so. Before that, a lot of people are doing kind of it's a work internship where you do 2 or 3 years, and then where you learn a profession, and then you do that profession. I think a lot of people would do better with that program versus going to university. But you said that you were really interested in research. You said that this was something that, yeah, you liked and you wanted to pursue further, and now you are a researcher, right, at the AI Institute. And you said just lately you came in contact with hardware. Can you maybe tell me a little bit about this? Because you said originally, right, you're into software, and now a little more into hardware. How is that?
Yeah. I mean, looking back, it seems like such a contradiction that like I always, from like I said, like moving on from like a young age, like I enjoyed STEM, especially like math and physics. Um, and then like later on, and like computer science, but like the physics part I always enjoyed, but like it was weird that I also like early on I had a bad experience with robotics that like and like which I'm very happy like by learning to now that I enjoy it. I very much try to like reflect on things that I
Mm.
think I might not enjoy as much. But what's really cool is that like robotics is a great way to learn about physics because when you have to make a robot, you're dealing with the mechanics of real world physics, and it's really important to understand uh, a lot about physics when it comes to that. And so I think like it seems like a really actual natural thing for me to have wanted to study. And I've really come to appreciate that more because my background is more, like I said, in applied math and computer science.
Mm.
And so I have a lot of not like a lot of my information is there, but like I think my understanding of like a way to go about apply like essentially like from my perspective, I've always bought robot hardware and I've been able to interface and develop algorithms with it, but I've always treated it much more like a complete black box because of more of my background. And so I think I've gotten a deeper appreciation of trying to understand a lot of the underlying mechanics, and how different systems compare to each other. Like why would like what are the different properties of different system or sensors or actuators? How do those impact what you have to end up in doing algorithms? Because really, you can have smarter hardware, smarter software, and like it's kind of a balance. Like if you have really smart hardware, you don't really need really smart software, right? Like if you have a really good hand that's very compliant and soft, and it kind of like just naturally grabs around things. You don't really need a complex policy. But like if you have a very simple gripper, you might need to have a really complex sensor suite and set of software in order to enable the intelligent behavior. And I don't really know in terms of the long term what's the right balance between those, but my guess is you're going to want both smart hardware and smart software. And so I feel like I've done so much work in the smart software side of things. But my understanding of how to make smart hardware has just not been as so much. And what's been really great about being at the Institute is that there's a giant appreciation for that entire spectrum. And so we have such a giant, huge community of people there who are really just knowledgeable at such different depths, both on software or various like pieces of hardware. And I think that actually, going back to your point about university, I think was what was one of the most beneficial things for me and that research aspect is that like probably towards the end of my undergraduate years, I was spending more of my time and more of my time just like in the research lab around other like around the graduate students and other researchers because I felt like I was learning so much more there, applying the knowledge I was like learning in my classes. Like so it was really, really useful just from like a community perspective, honestly, just and like the connections to like work with people who are like publishing world-class research and know how to like think about problems. So that I think, yeah. Anyway, so I feel like to maybe get back to your hardware point specifically, though, I feel like I'm always interested in trying to understand like what do I just kind of treat as like the biggest abstraction and like black box in my tool set, and I always try to like figure out how I can learn more about it to like open it up a bit because there's always this kind of law of leaky abstractions where no matter what you want to treat as a black box, there's going to be some set of conditions at which point that kind of abstraction and model that you have for it is going to be wrong and it's going to leak out in a way that you don't expect. And so like it's always good to just be able to like dig deeper into the weeds to understand things. So I feel like in terms I've really come to that bifurcation of like, yeah, hardware, software, like I should really learn more about hardware. So yeah.
So I'm working for Microprocessor Industries here in Berlin, and so this is a robotic software startup, but we do have a lot of hardware over there in our lab. And so I see our engineers or machine learning engineers working with a KUKA, with a Fanuc robot, or with a Cobot, universal robot. And so can you maybe walk us a little bit through? So what is it working like in the AI Institute? What kind of hardware you have in your labs, and what are the robots you're working on?
Well, we have a variety of platforms, both that we have actually bought, and then we're actually building some in-house. For what I actually specifically work on, I actually almost exclusively work currently on the Boston Dynamics Spot, which is essentially, I'm sure maybe many people know, is the yellow robot kind of quadruped with a has an arm that we can control. It's got various RGB cameras and depth cameras, and it has a lot of nice components out of the box. Like it can essentially do mapping and localization. So it has really good kind of out of the box basic navigation, path planning, obstacle avoidance. And it has some nice control you can do with the arm in terms of like some impedance control. So you can, do either like command it for where you want it to move in space or make it apply certain forces. So it's not the best platform at all, I would say, for dexterous manipulation, for example. But our team is like interested in trying to look at other solutions down the line. But right now, I'm actually working mostly with the Spot.
And how many people are in your group? Because when I'm thinking about these kind of labs, because I know a few innovation labs here in Germany. So these are mostly within bigger companies. They're trying to find a space where people internally can work on different things. You start with a very basic cobot, most likely, or a 3D printer. So you would like to get people from the shop floor actually get in contact with yeah, new technologies, right? And a lot of people nowadays are able to afford these kind of new technologies for themselves at home. So are you able to get one of those, let's say you can use a spot at home because you would like to do and test something? Is that something that it would be familiar, or is that something, no, all the equipment stays at work because that's where we need them, right? Because there's always fight about equipment and who owns
Yeah.
it.
So some equipment is not so all the equipment that is like owned by like the institute, and like a lot of
Yeah.
equipment it can't be moved for so for example we have shops at the office where there's like 3D printing and other kind of mechanical engineering, and then there's some hardware that just can't easily be moved, like we have kukas and pandas, and like it's not really
Mm,
easy to like move those, and then like really we have some other mobile robots, but like with the spot, like no, like it's pretty standard. Like we could take them out and like bring them to other locations, but I haven't really seen people. I've not really heard about people bringing them home to work on. Specifically, like to deal with like the spot is like particularly, I think, not the safest thing to like interact with like in such a closed space, maybe as a home. Normally, like everyone just goes in and like works on the hardware, unless maybe yeah, that's my understanding.
so the spot is not a good alternative to a real dog.
Oh yeah, definitely not. I mean, for a wide variety of reasons, but maybe one of them is that like you should not be within like 2 to 3 meters of it while it's operating, due to like the fact that it can have unforeseen kind of safety failures, and it has a lot of mass to it, so it could hurt you. It's just when it's just like trying to walk around, and so yeah, yeah.
And these, is it so? Very often students ask me if I can guide them through their journey. I don't have a background in robotics per se, right? I have a background in mechanical engineering and a little bit of aerospace engineering. So, and but what I can see from the corporate side or from the work side, very often the most interesting thing is, yeah, what were the projects you were working on? How were you incorporated those projects? How was your impact in those projects? What was your part of those projects? And so you've been to Brown University and now in AI Institute. I guess a lot of people would like to do that step. Is there anything that you can share in particular what is very helpful, or what should students focus on when they think they would like to do the same kind of career path that you did?
I mean, I think one thing I reflect on a lot is there's a lot of ways to go about research, and there's a lot of different kinds of research, and I think that's really important to understand, in the sense that, for example, with how what kind of impact that research can have, and one kind I want to focus on are like tools, and things research that's useful for other people is really amazing. Like it's one thing to like publish a paper, and have some kind of maybe conceptual idea out there, but to have something that other people use is a really powerful thing. And so what I really want to emphasize is that I think for anyone who's kind of interested in either AI, robotics, or in general trying to go down this kind of like path, I really just suggest playing around with things, trying things out, and trying to get just work on projects that you think are fun and get them out there. I think what's been really, I think some of the, when I look back on some of the research I've done during my PhD, for example, one of the more impactful projects I was able to be a part of was essentially developing an open source package to enable commercially available virtual reality headsets like the Vive, to connect to a large variety of robots. And what was really powerful about that is that it was a really nice package that people could just download and use it to do downstream research. And so it was really great to like put that out there, because like not only did like we get to explore a lot of cool things off of that, but I guess like there's a lot of amazing things that happen when you start making something, and other people start using it, and you start to see a lot of unforeseen kind of ways for it to develop. So I just always emphasize a lot of iteration, playing around with things that exist, and just trying to make things that actually solve problems, I think is maybe just a very high level thing to follow, if that kind of gets at the question you're asking about.
I mean, in the very end, yeah, as you said, following the things that that you're interested in, I think it's definitely a good idea. And you just mentioned that solves a problem, right? So in business, it's always about this. In sales and marketing, you should ask, or in project management, you should ask yourself, are you able to ask the right questions to your customer? So what is the actually problem that we're trying to solve, right? I mean, there's different kind of technology that can help, that can solve problems. But in the very end, we need to really understand what is the problem that needs to be solved. And then based on that, we can do the next steps and find solutions for that. You just mentioned open source. My previous guest on the show, if I sort of call it, so the second episode was with Rob Knight, and he together with Trent, they were working on a hand, the Dex hand, and you might not have seen it. So it's a really great project, and it's an open source project as well. So last year was a pretty big year for humanoid robots. We have a few companies that are really pushing in that space, and with Brad Addock, somebody who's really yeah, likes to be how do you say, in the focus as well. Just yesterday, I read an article about Elon Musk should hire this guy and combine them with the Optimus to make things a bit faster, because he's always about shipping and delivering things. So if you're looking back last year, and we've seen a few, Optimus was one of them. So do you think so? This was something that you were expecting because you are in the, let's say, you are in the industry or you are in the research. You've seen other papers. You've been to events, I guess. Was that something that you have seen coming, or was that something that was surprising for you as well? So many companies working on humanoid robots.
A little bit of both, honestly. So I think about 5 to 7 years ago, the idea, like even quadrupeds just being around was like a what? Like I just feel like I didn't really see it around too much. And it really
Hmm.
was like with Spot, like you would see videos, but like it wasn't something, but like now I'd say in the last like few like 3 4 years, like well, like towards the end of my PhD, like I was mostly working on a quadruped like with the Spot. And I was just like, it was amazing, like because all the robots I'd ever worked up to this point were like wheeled. And so it's just so crazy to work like with the legged robot. And so I feel like that was such a marked point where I was like, okay, like quadrupeds are actually kind of working now. Like bipedal robots, they're still the kind of thing where I see in a lot of labs, and like they're just there's so much more limited behind quadrupeds. I'm super excited for like the future of like humanoid and bipedal robots. Um, yeah, I'm really excited about it. Like, and I think the fact that we're seeing so many companies pop up, that's something I don't think I expected as much. But I'm still, I think, I guess, like, I'm still think there's like a ways towards having these bipedal robots be as prolific as we have with the quadrupeds. I'll even put it out like some of the things I'm really excited in the near future. I think that we will see with bipedal robots more in videos that we don't see today that I'm hoping to see are like bipedal robots getting like tripped and falling over and then correcting up with themselves, right? Like you see that with the quadrupeds all the time. Not something you see as much with the bipedal robots because they have
Mm,
a lot of inertia and they'll slam themselves. It hurts. They're not so low to the ground. And
but
so I
we've seen
think
a few sorry to interrupt you, but we've seen a few videos now, and I mean the question is, well, how much of this is really working? But we've seen these videos, people kicking those robots or humanoids, so from the back or from the side to see how stable they are. And I think there was this Chinese, I think it was Unitree. That was one of the few latest ones where I've seen this behavior. But please continue.
Oh, I was gonna say, I think talk about like what I didn't expect maybe so immediately is what you're talking about, which
Oh.
is recovery ability of like to kick the robots and then to keep themselves upright is amazing. I think that those are really exciting. But I am specifically focusing on like robots are going to trip. They're gonna like they can get caught on something, they're gonna trip, right? So it's amazing that they can stop themselves from tripping. But I'm curious, what happens when they trip?
Mm.
Like, can
Oh,
they
okay, got it.
deal with that? Like, like what, like so like you can see this, you can see the quadrupeds, you can trip them. Like when you push them, you can push them so hard they trip over, they'll tumble, and then they'll get back up. So like I'm kind of curious about those situations because like I cannot speak to it because I don't follow the kind of bipedal work as much. But my understanding is like from what I've seen, we're still quite a ways from like how I think robust quadrupeds are today. That's all I'm trying to say. But I'm super excited about it, and I think we're going to see a lot of progress in just the next few years. And I'm super excited. So I'm just trying to say what I'm looking even forward for. Like I'm looking for, I think like I'm looking for the videos where you can really throw the humanoid around and it can like recover. But I don't know if we're quite there yet. And if we're not there yet, I don't know how realistic it is going to be to put these things in anything but relatively structured settings like particularly constructed factories and things like that. But I
Mm.
think we'll soon have humanoid robots out. Hopefully, I don't know those soon, but like sometime, hopefully.
You were saying that you were working mostly on Spot, so quadruped, but we I think the majority of people out there know like the most famous bipedal robot that we have, right, or that the world has. So Boston Dynamics is mainly famous for Atlas and the video that we have seen. And I think last year were two or three very famous videos where he was doing some not only those stunts, but working and handing over some working pieces. So, how much are you? You said that you're not following this too much, but how close are you to this kind of research? So, do you see other teams? Are you talking to them? Do you have them as much around as the spot? I guess so, not. But
I should say, so the as far my understanding with respect to the Atlas like so Atlas, my understanding is still kind of a research project at Boston Dynamics, and is
okay.
not in a form that is like use or like not like best used by other people that aren't people Boston Dynamics engineers, because it may not. It's still in that kind of production phase, I suppose. And so my understanding is they're not even really leasing it out for anyone to really be using it. And so we're not so like as AI Institute, we're not using it as kind of like a platform, but we are exploring other kind of really interesting embodied robots, to say the least.
Hmm. Okay, that sounds very interesting. I mean, there were a few. I think Digit Now is one of the first one had been deployed in like in business. I think the most famous use case now is their contract with or collaboration with Amazon. Yeah, and I mean it's a bipedal robot as well, right? So it stands on two feet. We have in no here in Europe we have 1X. So there's a company. I think they just announced they closed 100 million fund, and I think their robot is Eve. Their robot Eve is on wheels, but they have one. I can't remember. I think it's Neo on 2 feet. So yeah, I'm curious to see that one. Do you think? I mean, we obviously see that this is one of the first companies where Agility Robotics that is deploying a robot. I'm not 100% sure about the scale that these robots have been deployed, but yeah, just from your, I don't know how close your research facility is in contact with industry. As far as I know from my work here in Germany, because we're working together with a few universities as well, there's always a very close contact because the majority of projects need someone who funds them, and these are companies from the industries. Maybe you can tell me how it is in your facility in the AI Institute.
Yeah, I think it's the institute's a really it's a really special place right now because of the fact that it has a really nice mixing of industry and academia. And the way that's kind of instantiated right now is that we were given a very generous like seed gift from Hyundai to essentially just investigate very open research and trying to progress and push forward the possibilities of what we can do with robotics. And so in that regard, we are not trying to produce a product, and so we're not really like trying to like we don't have any end consumers or anything like that that we need to like interface or things like that. We're just developing and working on like fundamental research to try to like answer the really hard problems that need to be answered to like get robots out into the world and like do useful things. And so but we are and so we have a lot of collaborations with universities, and like a lot of different professors and students that work with us as we're like publishing research. And so in that regard, we have very much like kind of an academic feel and kind of I guess culture to it. but the kind of industrial kind of aspect is like we have a lot of funding, and so we have a lot of resources in terms of hardware and systems that we can get configured that you can't really do easily in an
Mm,
academic setting. And
mm,
because of that, we have a lot of teams and people at the institute who would be more like what teams you would see at some sort of company, who are helping run and actually do really good facilitation of resources, like with our compute, both hardware and systems and security and all these things that you don't normally have to do at a like at an academic level, maybe as like so it's kind of a mixing of those. But I guess I want to emphasize that we're not really producing anything or have any bottom line that we have to meet, which makes it also really good because I think there's a lot of other kind of in places or companies and things that are trying to do or are doing research as actively making a product, and they're succeeding, I think, in good ways, maybe making like products that are like leveraging cutting edge AI in ways. But like because you always have to make a profit, you might not be able to like maybe think a little longer term. And
mm.
so we have that kind of ability, which I think universities have fundamentally done a very good job of, or academia, I guess.
Is something that I see in product development, or in general, because you said that there is a connection between people who do research and then the industry in the background. But I can't remember the exactly example what it was, but there was a spin-off of a robot. I think it was for uh, I can't remember exactly what it was, but I think it was something that to load and unloading a truck or whatsoever, something that Digit would do, but Digit has 2 feet, right? So and it was on wheels, and the original project was from the university, and they were working on such a project, and then they were trying to do a spin-off and producing a product that went into production or manufacturing side. And what you see very often, and we see this in our company as well, without going too much into detail, very often we have people that you're working that are working on specific tasks, but they are sometimes so detached from the real world, so to speak, that whenever you take them and bring them, for example, in a manufacturing site or in a plant on the shop floor, so this can be eye-opening. Like, okay, I wasn't aware of that. This is what my work will be used for, right? And it can be an accelerator or can be facilitator when you uh, yeah, looking at your work from a different perspective, from a different point of view. So you're saying, 'cause this is the direction we need to do research on, because these are the important projects or the important problems that need to be solved. But when you take this and go, for example, into the industry, and then you show this to people that are working on the shop floor, let's say with robots, that maybe they have different needs and different requirements, and so they say, okay, in the lab it might be very useful, but here on the shop floor this is totally useless for me. So you're working for a feature, or you're working for something that has, I mean, obviously there are more than one use case or more than one customer, right? But sometimes I'm asking myself, if the exchange between those two worlds is not happening very regularly, then it can happen. Then they can separate themselves so far that there is research going on in something that has no, yeah, it's hard to say this, but there's no bigger value than only for that research group, right?
Yeah, no, 100%. I think one thing that a researcher told me a while ago that I think gets at this kind of idea is that you make solutions to problems, right? Sometimes
Yeah,
sometimes you might approximate your problem, and sometimes you might approximate the solution. So approximating the problem is kind of giving like yeah, we don't really need to solve this problem, like like you're kind of drifting away from what's really needed. And like that can often happen if you already have a solution, you already have a hammer, and you're looking to like turn something, like you're looking for the nail to hit, and so you're
yeah.
just trying to like make it into something that the hammer can like hit, right? And that can actually happen, I think, a lot in research, because you're kind of not, you don't have to solve the actual problem, you're just looking for something, you're looking to solve problems. And so if you have a solution, you might look for some construction of a problem that no one really has, and so
Mm.
you've made kind of an approximation to it. But like oftentimes you might just want an approximate solution, which is or you didn't approximate the problem, like you got the thing end to end, it's there, like you have a grounding of what it needs to do, but maybe approximating the solution is like it's not as fast as it needs to be, like we're losing a little money or something, like we need to, but like you're at least tackling the thing you need to tackle and you're getting there. So I think that kind of gets at I think there's a deep balance between people who are trying to like are very deep in solutions and trying to apply those to the problems, but you want to make sure like you're solving the problem you actually care about. So it's an important grounding. I agree, and it's a challenging balance. So yeah, no, I agree with what kind of you're talking about.
You have a lot of experience in research now. I think you said that you started your undergrad in 2014, you said? And now you've been for 6 months in the institute. Is there something that, because there you have people, I mean, there are very, very experienced people in that institute, right? So is there something within those 6 months that is different from the more than 10 years that you did in academia before that? Something, a moment where you think, I mean, this sounds like an interview question for a job. So at the very end, the interviewer always trying to ask, come up with a very unique question. But yeah, this is actually something I was interested in. Is there something that you said, okay, from the outside, this is such a huge name, and when you're inside, is my learning curve that big? Was there a specific moment where you said, okay, this is something that was very very specific for me? I can remember that, or would you just say this is just on a different level, and this is just what comes after that? What was before?
To me it was there was a lot of natural, it was like there's a lot of natural smoothing of it because like as a research scientist I'm getting to like work on kind of the general problems, and it feels very kind of similar in regards to like kind of doing research. And like actually one thing during my PhD I had a really hard time deciding whether I wanted to go into academia or industry, oftentimes because I would do industrial industry internships. So I had done internships at like Amazon Robotics, Uber, on their self-driving car team when that had existed, at Meta. And so I had a lot of experience doing like AI research at these kind of big labs. And it felt very similar in a lot of ways doing it at a university. But what I think really felt different for me when I actually kind of made the full transition into industry as of now, like one thing that's really stood out is just, especially at the Institute, having such a I think like it was very easy for me at my university to like I was in the computer science department in this one place, so I would interact with a lot of just like maybe a particular kind of CS with like AI. I just feel like the kind of different backgrounds I was experiencing was maybe not as much because we were all like people who are going to Brown, but like going to the institute, there's such a huge community of people with just different perspectives and teachings of how they've learned things. And so one of the things that I've like been that has been huge for me is I just all the time trying to get like meetings with people just to talk and have chats with them. And one of my favorite things to ask them is just like, hey, like what's like a resource you always go back to learn about like something core to how you think about things? Like what's your favorite like textbook or talk or
Mm,
just like piece of text that you read or video, or like what do you like that like felt like it solidified some concept to you that you feels really important to you? And like I that question alone, getting to ask so many different people at the institute and get all the different things from people who are referring to like certain physics things to like things I didn't even think like a design like documents or like other kind of things that I hadn't thought about, like it's the kind of thing, once again, like getting people who have such a background from industry to academia all come together working on different very problems from software to hardware. Like it's not something I was so thrown into the middle of as I feel like as a university. And so that was like a whoa, like wow, like there's a huge spectrum of people here. And I just want to like get all of it a little bit. Because I think like being in university, it's easy maybe to get caught up in a little bit of your own Kool-Aid and
yeah,
like you're all thinking the
bubble.
same ideology. But like I think like the like particularly the institute's really nice now because everyone's bringing their own little Kool-Aids together, and so I can sip it all. And it's been very educational.
Is there a due date to this time now, or to this position in the AI Institute, or is this like permanently at the moment?
Yeah, no, it's permanent. So hopefully,
Mm,
right now we haven't published any research as an institute. So hopefully in the next year or so we'll have stuff either coming out this year. So we're gonna. I think it'll be exciting to show the world what we've been working on.
interesting. Yeah, I'm very curious about the results from that. I'm sharing a lot of videos and papers on my account on LinkedIn because people are really interested in what's happening behind the scenes, right? Not only was getting deployed, but what are people working on? What is the on the very edge of what is happening in AI and robotics? And yeah, I was very happy that you said, okay, let's do this. I think you said immediately yes when I asked you, so I was very happy. And I think, I mean, this is just a third episode, and time will tell. But I'm trying to do this for the longer run. So there might be the possibility in the not too far future to actually being able to talk to you again. And I mean, my wish would be actually visiting people on their work and see what they're doing, what they're working on. In manufacturing, very often it's limited because there's machines or technology are not able to see, blah blah blah. But yeah, maybe there will be a time where we'll be able to visit you. That would be awesome. Or if
Yeah.
you're in Berlin, you can come by any time and visit me.
Yeah, I would love that. If you're ever in the Boston area, please let me know, and then I'll definitely let you know if I ever come over. That would be great. I would love to visit. But and then yeah, no, hopefully soon we'll have some stuff and video stuff out, and then I would definitely be interested in talking with you. And it's always been fun to chat. So yeah, thanks for talking with me and reaching out. It's been great.
As a fun fact, our CEO, so one of our founders, he just stepped back from his role as a CEO because he wanted to go back and spending more time on the product, which is great because he's a genius. And we just got an American CEO from the Boston area, and so I'm not particularly now going to Boston. I'm just saying, so it's not too far from microPC because we have an American entity that is situated in San Francisco, and but now we have a CEO that is sitting in Boston, in the Boston area. So let's see. Thanks, Eric, for taking the time and for having so much energy. I really enjoy talking to you, and I will talk to you again soon.
Sounds great. Okay, I'll catch you later then. Have a good one. Have a good week.
Take care. Bye bye.
See ya.